So hello everyone, welcome you all to this new video. So in this video we are continuing with the problems related to Green's theorem where we have left in the previous session. We have solved two problems, right? So again we are having two important questions in this Green's theorem concept that is very important ones and multiple times repeated. So let us see the question now. Fourth one, use Green's theorem in the plane to evaluate the integral 2x square minus y square dx plus x square plus y square dy, where C is the boundary of region bounded by x equal to 0, y equal to 0 and x plus y equal to 1. Okay, so according to the given condition, let us draw the graph here. Y axis, x axis. Okay, what they have given? One is they have given x equal to 0 line. Okay, so we have drawn that line first. This is of x equal to 0. One is y equal to 0. And one more is x plus y equal to 1. Okay, x plus y equal to 1 means when x is 0, y should be 1, and when x is 1, y should be 0, right? Then only we would be getting the answer as x plus y equal to 1. So how to represent that? So here at this point, the coordinates are 0, 1, right? So in order to satisfy this condition, in this side also we should be having the coordinates 1, 0. Okay, 1 is 0, other one should be 1, and 1 is 1, other one should be 0. So when at these 2 points 0, 1 and 1, 0 it satisfies. So from these 2 points you draw one straight line, and the region you shade where all the three conditions intersect. Okay, and draw a perpendicular from x axis to y axis to get the limits. Okay, yeah. That is first draw the limits of x here. Yeah, let us write the limits now. Consider this x plus y equal to 1. So we would be getting y equal to 1 minus x, right? So when x equal to 0, in this case the value of y would be equal to 1, and when x equal to 1, the y value would be equal to 0, right? So the limits are, for x it is from 0 to 1, okay, because the values are from 0 to 1 and 1 to 0 itself. And for limits y, see here it starts from 0, and here x plus y equal to 1 and y is equal to 1 minus x. Okay, so that's why the limits are from 0 to 1 minus x. Okay, so like this you should be finding the limits first. Now solve the problem using Green's theorem according to the question. Now in place of m, what it is given? 2x square minus y square, and in place of n it is given as x square plus y square, right? So now first dou m by dou y, that is partially differentiating this with respect to y. Here we don't have any y term, here we have one y term. By differentiation of y square is 2y, so we are having minus 2y. Dou n by dou x is equal to, with respect to x now this term goes, differentiation of x square is 2x. Okay, so dou n by dou x minus dou m by dou y is equal to 2x minus of minus 2y, that is 2x plus 2y, or we can simply write, taking 2 common, 2 into x plus y, right? Now solve for the integration. Now the simple integration part, that is dou n by dou x minus dou m by dou y dy dx, right? Solve for it. So outer I am putting the limits of x here, and here I am putting the limits of y, 0 to 1 minus x. So the value of this is 2 into x plus y, that I am writing it here, dy dx. Okay, now do the integration part. First do the inner integration with respect to y. So 2 into x plus y, okay, that is take 2 common here outside and then do the integration x dy. X dy means x is common, integration of dy is y, so xy plus y dy, that is y square by 2. Limits are from 0 to 1 minus x dx, 0 to 1. Now put upper limit and lower limit, that is x into, in place of y, 1 minus x plus y square, that is 1 minus x the whole square by 2. Okay, minus 0, because the lower limit is 0. If you put the y terms as 0, both terms would be equal to 0, so minus 0 dx. Okay, so 2 is equal to integration of 0 to 1, so multiply here, x into 1 is x, x into minus x is x square, so this is of the form a minus b the whole square. Okay, that is equal to a square minus b square plus 2ab. Okay, so if you split it and write it, you would be getting as 1 plus x square minus 2x the whole divided by 2. Okay, into dx. Now do the further simplification. X minus x square you do the cross multiplication here in order to take the common LCM, so we should be multiplying this both terms by 2 plus 1 plus x square minus 2x the whole divided by 2 dx, right? So here 2x and minus 2x gets cancelled, and here 2 gets cancelled, and we would be left with x square minus 2x square, that is minus x square plus 1 dx, right? So solve putting the integration, integration of minus x square is minus x cube by 3, and integration of dx is x. Limits are from 0 to 1, so put the limits. Upper limit minus 1 cube by 3 plus 0, lower limits plus 1, and lower limits are 0 cube by 3 plus 0, right? So this would be gone, we will be left with minus of 1 cube, that is minus 1 plus 1 by 3 minus 1 plus 3 by 3, because we are doing the cross multiplication, so you will be getting 3 minus 1, the answer as 2 by 3. Okay, so this is our final answer, 2 by 3. Okay, for this problem. So note it down, this was the problem, very simple. So we have one more final question, after that let's wind this session up. Using Green's theorem in plane, this is the next question, to evaluate the integral from x square plus y square dx plus 3x square y dy, where C is the circle. From the given equation of the circle is given as x square plus y square equal to 4, traced in the positive sense. Okay, so here we don't have any semicircle and all, they have given the direct circle question. Okay, so now let us see how to solve this problem. First, draw the plot. Okay, since they have given one circle here, so I am drawing one rough circle, y-axis, x-axis. They haven't given any other condition, so shade this circle. Okay, from positive sense, so we should be starting from upwards to downwards. Okay, and the value of the radius is for 2 square, so the value of radius is 2, right? So here we have 2 comma 0, this is 0 comma minus 2, minus 2 comma 0, 0 comma 2. Okay, so these are the 4 points surrounding this circle. So now solve the problem. First, limits of x, the limit x tends from minus 2 to plus 2, right? minus 2 to plus 2, and limit y, so this is the equation, right? X square plus y square is equal to 4. If you solve separately for y only, we would be getting y square is equal to 4 minus x square. So y would be getting it as plus or minus square root of 4 minus x square. Okay, so the limits of y are from minus of square root of 4 minus x square to plus square root of 4 minus x square. Okay, so these are the limits of x and y respectively. Now solve. In place of m they have given x square plus y square, and for n they have given 3x square y. Okay, so first dou m by dou y, partially differentiate this term with respect to y. Here we don't have any y term. Here the y square differentiation is 2y. Dou n by dou x is equal to 3x square y. With respect to x we should be doing, so y 3y is constant, the differentiation of x square is 2x, so you will be getting 6xy. Okay, now dou n by dou x minus dou m by dou y is equal to 6xy minus 2y, or we can take 2 common and we will be writing 3xy minus y. Okay, so this is the required. Now solve using the integration of this part. If you integrate this, you would be getting, here 2 you take it common outside. First I'll write the x limits outside. Here minus square root of 4 minus x square, square root of 4 minus x square, 3xy minus y dy dx. Okay, so solve now. Minus 2 to 2. So with respect to y, so 3x is constant. Integration of y is y square by 2 minus y square by 2 minus square root of 4 minus x square, square root of 4 minus x square dx. Okay, now upper limit minus lower limit. So here 3x by 2 you can take common outside, because substitute only for limit y, right? So we have y square, so upper limit is square root of 4 minus x square, so that is plus square root of 4 minus x square the whole square, minus the lower limit is minus square root of 4 minus x square the whole square, minus 1 by 2. Okay, for this part minus 1 by 2 take it common. Here we are left with again y square, so it is square root of 4 minus x square the whole square, minus of minus whole square dx. Okay, solve it. (3x by 2). So here root and square goes. Here also root and square goes. Everywhere the root and square would be getting cancelled. Okay, so we would be left with 4 minus x square again. Here when we do the whole square part, this negative sign also goes, so we are left with minus of 4 and negative sign into here negative we have, so this would be plus x square. Okay, here also minus 1 by 2, the same thing, 4 minus x square minus 4 plus x square. Okay, dx. So 4 minus 4, 4 minus 4 minus x square plus x square getting cancelled, so you would be left with 3x by 2 into 0 minus 1 by 2 into 0 dx. So it's both are getting multiplied by 0, so it would be both would be getting cancelled and you would be getting 0 dx, right? So if you do the integration of dx also with it's getting multiplied by 0 only. So our final answer is 0. Okay. So for this particular problem, for the circle, the answer we would be getting as 0. Okay. So yeah, this was the problem. Note it down. So that's all for this video, guys. In the next video, we are going to see with some more concepts. Thank you.